All right, second topic, compilation process. Just very quick bit of theory. First, let's start with C as a language. Okay, we call C a language, so let's draw an analogy to an actual language, English. English has an alphabet which consists of A to Z, both lowercase and uppercase. C has the same alphabet. You can use numbers in English. Generally, we just use base 10. And in C, you can also use numbers, except you have bases 2, 8, 10, and 16, right? Uh, Words are just words in English. And C, you have these things called tokens, which we will touch on that. Sentences. Sentences are just words arranged grammatically. The C equivalent of a sentence is a statement. A statement is are tokens. A statement is made up of tokens arranged syntactically, right? And a paragraph equivalent would be a block of statements. Uh, a chapter or a book would be a program, a singular program. And then an equivalent of a library would be a library consisting of multiple programs, right? All right. The C standard. So C, believe it or not, is still evolving as a language. The last the last standard was released on October 31st, 2024. It is C23. It will be linked down here. I'll link it in the description. Uh, yeah, C is evolving as a language, just like any other piece of software you use. You get updates, right? So C gets updates. In fact, there are 10 new keywords between C17 and C23, all 10 of which you guys won't be using for this course. All right. So tokens. All right. I'm not going by the exact strict definition of tokens provided by C. They have an exhaustive list. You can find it in section 6.4, page 62 of the standard. Will be linked in the description. All right. What are tokens? Tokens are the building blocks of a language. If we go back to our analogy, words. Tokens are the words of C. With the alphabet, you can just make up stuff, right? But words are what have meaning, right? Words are the smallest unit that have a meaning in English. Similarly, tokens are the smallest unit that have a meaning in C. We have a few different types of tokens. Again, C has a proper list. I have not strictly abided by that list for simplification purposes. You can go and take a look at that. Identifiers. Identifiers are just naming things. Whatever you want to call something, a function, a variable, whatever you declare, you call it something. That something is called an identifier. It identifies something. Keywords. Keywords are reserved words that have some special meaning in C. So keywords tell the C compiler, hey, this means so and so at this point, right? There is an exhaustive list of keywords in the C standard, also can be found page 63 of the same document. Literals. Literals are just any constant. So a number like 1 or the character C, right? String literals. String literals can generally be considered a subtype of literals, but the C standard does not classify it as such. It is its own separate thing. So I've made it its separate thing here as well, right? Very important point to note is that string literals are not the same as strings. String literals are any literal strings that you write out, like say hello world, right here, right? If you write this out actually in your code, that's a string literal. If you store that in a variable, that variable is a string and that is not a token. Very important distinction. Special symbols is just operators and punctuators just used for operations like addition, subtraction. And then punctuators is just like commas and semicolons at the end of statement. Those braces, that kind of stuff is punctuators. Okay, the compiler. What is the compiler? I'm just going to read this right here. Compiling in general is a thing used to describe collecting data and presenting it in a different manner, usually one that is easier to comprehend to the one being presented with such compiled data, right? So the compiler is going to take your C source code and then translate it into machine code or binary, which your computer understands. So that's the job of a compiler. It's basically a translator between your C code and your computer. Uh, the compiler is actually many different uh, parts or processes or programs bundled together and glued together as one. For now, we'll just look at it as the compiler and the linker. Uh, the compiler is broken down into much more complex stuff, but that is way beyond the scope of this video. So I'll just leave that for you guys to just go and read about if you're interested. It is in no way going to help you in C, but it is very interesting to read about. So the compiler part of a compiler takes the C source files you give it, right? And then it compiles them into something that's known as object code. Object code is understood by your operating system. It is actually just binary in most cases. Modern Windows, anything above Windows 8 and maybe even Windows 7, I'm not sure about that. Linux, Mac OS, all of them, object code and your final executable are stored in the same format. There is just a minor difference in them beyond the scope of this video. So, object code is platform dependent. That means your operating system affects your object code and your CPU affects your object code. And the linker. The job of the linker is to link stuff. So you have just multiple object files thrown about. Object files are a one-to-one map of your C files. Each C file you compile gets its own object file. But say you include something like standard input output, standard stdio.h, right? The job of the linker is to string together these multiple object files and add any headers, libraries you include and use in your program, right? So when you include stdioh, linker is what actually goes and finds the actual code and then bundles it with your program so that it can actually run, right? And then the loader. The loader is just the part of the operating system that loads the compiled program into memory and readies it up for execution. Just a little touch on loader. I'm not going to explain it. You'll learn more about this in the operating systems course. All right, that's it. Bye.